Okay, so we're at 10 o'clock here UK time, which suggests it's session 3 of 24, which is using Java 9 modules, Chances and Challenges by Rafael Winterhalter. The sponsor of this session is IBM, and participating Java user group this time around is, again, the Melbourne JUG. This is, or Melbourne JVM group. This is the third session for them in a row. I mentioned IBM as the sponsor. IBM actually have done some really interesting things over the last year. They had a very exciting Java 1 with a few things that they've open sourced and are being currently part of in an open environment. We have Open Liberty, which is an application server, open source application server, optimizing cloud native Java microservices. That was actually one thing I worked on just as I was in my last few years of IBM. I was working on Liberty, and that was a really exciting technology actually. So do check that out. With Liberty, you can they implement microprofile, and microprofile is the new enterprise Java for microservices architecture, and this is fitting very neatly in with the new EE4J mentality as well. So do check out microprofile.io as well for your enterprise needs. One thing that has happened this year, which is very exciting, is OpenJ9, which is IBM open sourcing their JVM offering. So they say there's a low memory footprint, a fast startup time, and high application throughput. So very interesting there. So do check out those links. And thank you for IBM for sponsoring. IBM will be paying for some of the food and drink at Melbourne JUG, as well as some of the other user groups, some of the other sponsors that we've had the last couple of sponsors. Zero Turnaround, obviously, the main sponsor for the virtual JUG and vJUG24 as well. So big thank you to Zero Turnaround. With Zero Turnaround products, you can download trials for free at zeroturnaround.com, and that includes Xrebel and JRebel. So do check out those products as well. If you're on Slack, you can go into the live session channel to ask questions and to have discussion. If you're not on Slack, if you go to vjug24.com, there's the link there on the Slack icon to join Slack, and it's entirely free. Twitter, our hashtag is vjug24, and if you've only just joined us, increase your video quality on your video on the embedded link by just clicking that settings cog and choosing the highest resolution you can. So let's have a look in our channel first. Let's actually first jump to the Melbourne JUG to see if the Melbourne JUG are still there. Hey, Melbourne, how's it going?
Hey, Simon. How you going? We're still around. Still a lot of us hanging around. And
some people eating quite a few of it.
Oh, excellent, excellent. What time is it there in Melbourne, out of interest?
We've just hit 8 p.m.
8 p.m. Right, nice. So we're 10 a.m. here, and we have Rafael Winterhalter as well. Rafael, how are you doing?
I'm fine, thanks. How are you?
I'm okay right now. We'll see.
Yeah.
We'll ask me again this time tomorrow. We'll see. But and what are you in Oslo right now, Rafael?
I'm in Oslo right now. Right, just came from Vox Belgrade and back
cool.
home.
How was Vox Belgrade? I thought I saw some pictures and it looked amazing actually.
Yeah, great show.
Yeah.
So it's nice to give a session from your home as well.
Absolutely.
Allows you to be with the family and still do these things, right?
Yeah.
So
absolutely.
Thanks for having me.
And so you're giving a session on Java 9 and modules. So actually, let's go back to the Melbourne JUG. There's not many people there, but let's do a show of hands anyway. Who's running Java 8, for example, now? Okay, good number on Java 8. Has anyone migrated over to Java 9 yet?
Well, I wouldn't say migrated. Greenfields?
Greenfield. Okay, yeah. So has anyone in their development environment started using Java 9?
Just.
Okay, so it's still a very early thing. Let's go over to Rafael and let's talk about Java 9 modules. One of probably the biggest feature in Java 9. So Rafael, over to you.
Yes, I'll just start with my slides right away. So wait, I have to probably screen share first. That's a good idea. So yes, hi, good to meet you all. My name is Rafael. I'm a software developer here in Oslo, and I'm also maintaining some open source frameworks, or helping out at least, which are fairly bound to the JVM. For example, I'm one of the core developers of Mockito, the mocking library, Also, I write my own library, which is called Byte Buddy, which is doing code generation. And it's used quite broadly. For example, Hibernate's using it. I'm helping out there a bit as well for the code generation parts. And all these libraries basically depend on this tight integration which code generation has into the JVM. And you probably heard of Java 9 being more restrictive about certain things. And that gave me the privilege to explore Java 9 at a quite early stage, because I had to actually change fairly a lot in my library to accommodate the new restrictions. And today I want to talk about what these restrictions mean, why, even though they cost me a lot of grief and a lot of work, why I still think these restrictions are a very good decision for the JVM's future. And I basically want to explain my view on it. And this is an important factor here, and my view and my opinion on it, because a lot of people will tell you a lot of different things of Java 9 and the module system in particular. And I also try to resolve why so many people have so many different opinions about Java 9, where the controversy lies in there, because Java 9 actually does break a few things that have worked in Java 8 and before. And that's probably why you haven't all migrated to Java 9 yet. It's not a trivial migration. It's not a hard migration either, because the work is mostly done by the framework developers that are fairly low level. So end user developers shouldn't be so exposed to these changes. But still, it might hit you. And today I basically also want to explain to you what you have to look out for. Yes. So what I want to start with is something you all know, because modularity in Java isn't a new concept. Actually, modularity in Java is a fairly established concept, because you all probably have worked with this, right? This is a source main Java folder, which has a classes in it. And this is Maven, right? So you have a POM file at the root, and then you have your API and your internal classes in this module. And this is already a module. It is a build time module, though. It's not a runtime module as Java 9, but the things aren't so unequal. So if you define a module like this foo artifact, you can define another artifact, bar. And if you want to basically depend on foo from bar, you just declare it. You declare dependency. You say bar needs a working copy of foo. And once you declare the dependency, you basically import the entire artifact that you have built previously. And that's how you can reuse modules. You just build them once, and then via this dependency, you make it accessible to another module, right? And Java 9 modules, they don't work so differently from that. Java 9 modules are more or less the same. This time you also have a folder. It's called differently. It's called the way the module is called this time, which makes sense, of course. And it also includes classes. Your API foo Java and your internal classes cooks Java, right? And the way you define your module, and you can still, of course, use Maven, but the module descriptor, the primary module descriptor, now lies in the project as a Java file, because now we have a new type of Java file, which is module-info.java. And the choice for this name is similar to package-info.java, to use a name that is not a valid Java class name to avoid collisions, right? So package info isn't maybe so used. It's mainly for JUGSB and annotation-based things where you have to declare something on a package level. Here you declare something on a module level. And the most trivial module just has a name, but it doesn't export anything or import anything. It's the most basic Java application that is a module. It's just a named artifact, right? But of course, you'll extend that. You will export your API. And this is something new. In Maven, we cannot choose what to export. And the reason for that is that Maven just operates on build time. Maven doesn't have a way of interfering with the runtime to prohibit certain packages or certain classes. It can only create an artifact in the way that the JVM supports modularization, which was basically non-existent until now. But so far now we have already shielded the internal implementation away, which is basically the biggest change from using Maven modules compared to using Java 9 modules. So this is exported now, and if we have another module, which is bar, for example, here, again, we have API and internal classes. Now we can declare this module, and we can require this foo module in order to use it from the bar module. And important distinction here, when you do exports, you specify the package. And if you do imports in a way or require another module, you refer to the module name. There's no wildcard exports or anything, which is basically an incentive by the language developers to people to design modules in a way that the API is in ordered packages, right? That you don't just spread something in deep hierarchies to make it easier to basically know what the API is also as a developer of this module. Right, and now we import this, and important to before now, the cooks class is not visible to the bar module, which is a big improvement, because before, and you probably all have experienced that, you would see anything that a module brings with it, right? You maybe use this one small library which has a very thin API, but it has tons of dependencies. It has Guava, and it has all of these things that you do not officially require in your module. But you might just do a static import somewhere or a quick import using your IDE, and you might get a class and get dependent on a class that you actually didn't mean to build into your project just by transitivity, right? So, and this is basically already what the module system is. This is what most developers will need to know to get started. There's not much more to it, and that's why I say the module system, it is easy. It is really, I'd say, and again, this is the opinion part, a very well-designed abstraction around modularity, but it is still a bit distinct from what we have already. So with build tools, you describe, for example, a POM file or one of these build Gradle files, and there's tons of build tools that have their own way of describing dependencies. And with Java 9, we finally have a way of unifying this sort of dependency description and module description, which is a huge advantage because you drag this out from your build tool. Build tools are not only module descriptors, they also are deployment descriptors. They explain how your build is executed. They often have APIs for custom tasks, and most Maven files and most Gradle files and so forth, they are fairly extensive often. And this basically distracts people developing software from the application side of things, where you actually only want to describe how your project is structured, not how it is built. So it's great to have finally to have a format for this sort of thing where it's focused on what it's actually about. Also, we have a different scope of modularity now. The JVM knows about Java modules at runtime and can enforce a lot more at runtime, which Maven simply can't do. Maven basically disappears out of your project once you deploy an artifact and it's no longer available. And at Java, even at compile time, so the Java C compiler can know if you're crossing module boundaries, right? Also, something that's very nice about Java module declarations is that they actually are declarative. Especially in Gradle, you can do a lot of things using programmatic style descriptions. So you can say, if this weather API returns that today it's sunny, I want to depend on this one, and otherwise I want to depend on this one. And of course, nobody would do that, but you get the direction. If people just think complicated enough, it's very easy to build very complicated dependency graphs, because you can actually weave conditions and all these things, which makes it much more complex to process, not only for machines, but also for humans especially. And with Java, this is no longer possible, which I think is a very meaningful restriction to these modules. And again, then we have what I already mentioned. The unit of modularity is now the Java package and not the entire project. With Maven, you can only say, I want to import this entire module, but you cannot say what packages of this module you actually want to depend on and what transitive dependencies you want to depend on. With the Java module descriptors, you can just import the packages that a module actually wants to expose to you, which gives you a much more fine-grained and much more clean approach to modularity. So, what people often do not think about when they think of modules, and why is this such a big problem for some library developers, is the fact that this fundamentally changes the way that Java processes classes and processes programs. Because previously, if you had two different Maven modules and you would run a Java program, then these two jar files would end up on the system class path, right? This is how Java has always worked since version 1. You have jar files, you specify them as a class path, and all of these jars will end up on this class path. And being on this class path, there are no more boundaries left. Between the foo and the bar module, there is no restriction of access. And a lot of libraries have relied on this assumption a lot. So for example, if you use Spring or Hibernate, one of these libraries, they will interact with your code a lot. And they will make use of the assumption that they are basically having full access to any classes that you supply on the class path, because they can scan the class path, for example. They can even parse class files and do all this magic that most people do not think too much about, but only use and make use of, right? With Java modules, you could, in theory, and this is not yet possible, but it is a future extension that is planned as far as I know at the moment, you could, in theory, even have one jar file that contains 2 modules. As I said, right now, that's not possible. Every jar file has to contain a single module, but in the future, this might change, right? And even in the future, when this has changed, you might deploy this artifact, which is one jar file, and put it on the module loader, which is now superseding the class path in favor of this modularity. And once you deploy your application, at runtime, these 2 modules will be physically separated in a way. Well, not physically, but by the JVM. These modules won't have access to one another unless they declare this in their module descriptor. And this information that module bar reads module foo is retained at runtime. So if now, for example, Spring tries to access your classes and you have not exported your types to Spring, this is no longer allowed. And this is the big change with Java 9. This is what basically is the root of a lot of the controversy around Java 9. A lot of people build very complicated frameworks. A lot of complicated Java applications are out there, which are basically very much breaking this assumption. And it is a lot of work to figure out what happens in your application once these access boundaries suddenly are introduced. And especially for applications that do not break necessarily because of these new restrictions, but change their behavior. And I'm a consultant in Oslo. I work a lot with enterprise. If you think of Java 9 in the context of like 10-year-old enterprise applications that were built around Java 4, where a lot of things are a bit awkward already today, and with Java 9, this feels like an impossible task to update some assumptions that are made in these applications, and this is why a lot of people got scared/angry about the changes that were introduced. And of course, this is a cost that will face anybody of us. Then again, as a consultant, maybe that's even good, because in a way, work means this kind of work means that I have something to do. But in the end, this makes the JVM a much more safe and a much more reliable platform once we got through the pain. But there will be some pain, at least, because you have to update your applications, at least once you migrate away from Java 8. And still, today, there's a sort of a transition period where you can get away with a lot still. And I'll talk about this in a minute. Right. So another implication of this module system, I already mentioned that, but just to make it clear here, is that if you use Java modules and you have a module cooks that depends on module bar, that depends on module foo, then module cooks will not be able to access module foo. You don't have transitive dependencies. With Maven, this is always happening. Maven just can describe what artifacts to put onto the class path in the end, right? And all these jar files will be available on the same class path and see each other eventually. That's why Maven cannot restrict this form of visibility. And that's why Maven doesn't offer you true modularity. And this is why something like Jigsaw actually was necessary. Or Jigsaw, it's the Java platform module system. Jigsaw is just the project name. So the module system changes this default to only transitive, to non-transitive visibility, which is a much better default, because now module boundaries will be much cleaner. And if you work in an enterprise application and you try to import something and you have all these weird classes available for import, all this will go away in the long run. I think this is something that young Java developers eventually will not even remember anymore, how it was like to work without modules. Once you get used to it, it's actually a quite nice property that Java programs get now, once you modularize them, of course. You can fall back to the Maven default if you actually want to expose a dependency. Often you don't want that. Like, let's say you implement an HTTP client, you don't want to expose your dependency onto netty. You don't want to expose all these netty classes. But maybe if you expose, I don't know, Guava or something, maybe this is a utility package of your own, and Guava is just something that comes with it. So this is something you want to do, and then you just declare this transitive dependency where the old default with these fall-through dependencies still exists. Right? So what will you do if you write a module today? Let's say you implement this module bar, and you will definitely have dependencies in this module. And some of these dependencies will be your own dependencies, but the most important factor around modules in the JVM is that the JVM classes themselves are now modularized. And the JVM, if you are familiar with the entire standard class library, it is quite huge. We just celebrated 20 years last year, and of course in these 20 years things have changed a lot. We started out with Corba and all these things. The XML was and is still big, but a lot of stuff was added. A new collection API was added at some point, and that basically gives you a very large range of available classes. And all these classes are now split into modules such that you can tell the JVM and the compiler and the runtime what modules you actually do require, and then the JVM will only make these classes available to you, which makes it also much easier to learn Java, which is a benefit that many people don't see maybe. But you can now start with a very tiny set of standard class library classes and then expand from there. So let's say you have your own module. We already covered that, right? You have your own API, some utility package or something. But you will also depend on the Java XML package. And the Java XML package is now exporting the SOX parser, which is used to basically just parse XML files, and you get events every time a tag is found, or an attribute is found, or a value is found. But just by looking into the example bar module, a developer can now tell what this program is about. It's doing something with foo, which hopefully has some documentation, and it's depending on Java XML. So you already know this is some XML processing application before you would actually have to look through the code and find out what something is doing. This gives you already a good orientation, and as I said, it will also limit you to the classes that you actually do require. There's a fourth module in play here, which is the Java base module, which is always available. You always implicitly import Java base, and Java base includes all these classes that you know and love, like string, integer, also the I/O stuff like the streams, the input stream, output stream, and of course the util classes like list or set, but also quite some more. But it is basically now the class library that you need for basically anything, no longer the standard class library that allows you to even run a web server and all these extended features that the JVM includes, which you probably won't need in most projects. But if you need them, you can now tell everybody by just declaring that in the modules that you export, right? So this is how you would build up a modularized application these days if you start from scratch. Of course, there is a transition period. If you go on Maven Central today, you will find that there are very few projects, almost no projects yet, that do support Java modules. So you need to interact with non-modularized code. And that is, of course, possible in the JVM, even with Java 9. Let's say you have this old dependency, which is still a POM described artifact, and you want to import it, then you can still write requires example foo in your module descriptor and reference this non-modularized artifact. And the way this works is the system is called automatic modules. Even with modules, without a module descriptor, artifacts can be treated as modules by the JVM. And what the JVM does is that derives the module name from the jar file. Maven has this convention where any class is called group ID minus artifact ID minus version .jar. And the version part is stripped away from the JVM, and the dash is replaced by a dot. So this module will automatically be named example.foo. And that way you can require it as an automatic module. This is, of course, a bit shady to do because the jar file name might not be stable. You might change the name, you will still want to run your program. So as a transition property, you can now include something in the artifact metainf manifest file, where, for example, declare the entry point of every jar file, like the main class, and you can basically say automatic module name example foo, And you should watch out for these. A lot of library vendors have already included these things. Guava, for example, is now available as the stable automatic module. I think Google got the name actually, but it's not Guava, at least, because the recommendation for these automatic module names is actually not to use the jar file name, but to use the root package name to avoid collisions, because modules cannot have the same name, right? So you can get started with modules more or less right away, even if your dependencies are not modularized. And that's also true for your applications, of course. You can start to modularize the low-hanging fruit, start with that, and you don't have to do it in a particular order, because, of course, you don't want to do these big bang modularizations, which can be quite painful if you figure out things don't work anymore along the way. You can, of course, also depend on modules or modularized jars from projects that are themselves not modularized. So now we're doing it the other way around. So you want to describe your main module, for example, as a non-modularized project, a simple POM project, and import example foo. You can, of course, do that. And the concept for this by the JVM is called the unnamed module. So now we don't have automatic modules, but we have unnamed module. And the abstraction by the JVM is basically that any code that isn't itself modularized is loaded into this unnamed module and is basically treated like a module that imports any module that exists in the JVM, which means that it is being able to access all code more or less. Right? So you can still rely on the Java XML stuff, and you, of course, also have the base module available. And if you declare dependency on the jar file that is example.foo, you will also be able to see that. Right? However, if you import or rely on classes that these modules do not expose, then your applications will break. And again, this is the big controversy about Java 9. If you have dependencies on internal packages that are now no longer exported, and this is true for example, Guava, or also the, and especially the Java core libraries, your application will fail at startup. And it will not fail like when it's booted. It will fail once this, for example, base64 encoder class is used. And that's not true for only your code, of course, but it's also true for all of your dependencies. So let's say you run an old version of the JBoss server on a Java 9 JVM. Then you have to make sure that no code within JBoss is relying on these internal classes. Otherwise, your application will fail on startup. And that's, of course, pretty bad. And this is what makes updates to Java 9 so scary. And as I said, I'm an enterprise developer myself. This is scary because you have production applications that have to run. They handle important things, and you don't want to be distracted by these sort of restrictions because normally the project itself might already be on fire and you have other things to worry about. So, and this is a concern, and this will take time. I'm sure it will take some time to process these sort of errors. The good news is that you probably don't have to worry too much about it right now. Java 9 just came out, and I think Oracle is quite aware that this will take some time to be processed. And as we saw in the beginning, none of you raised your hand when it was asked if you use Java 9 already. I think few people do. And as a matter of fact, Java 9 is already end of life in March 2018. That's not so far from here, where the first long-time release is released. The new Java versioning scheme now dictates that there's a new release every 6 months. And this will be the first release that is actually supported for a long while. So my personal prediction is that most people will actually wait for that release. And the next half year will be some sort of tryout things. But I encourage you to do that. Try your applications.
Is that right, Rafael? I thought it was the September release, which is going to be the long-term release.
Oh, is it? I might get this wrong.
I think it's 18.9, which is the long-term release.
Okay, then I reverse my... I think most enterprise people will wait for this long-term release because the enterprise release cycle doesn't allow you to update like something so major as a JVM. So then we have almost a year to get used to these things. But as I said, like try things out, see what breaks. Spend time the next month to update your dependencies, because a lot of dependencies like Hibernate, Mockito, also the Spring framework, Spring Boot now with Spring Boot 2 will support Java 9. this is work, right? You have to do anyways. Now is a good time over the next year, before also Java 8 is end of life, which now please correct me, Simon, is then also, I think this is similar, like the same time as the long-term release.
Yeah, that's right. So I think Java 8 is at least September 2018.
No, I know it's at the same time as the first long-term release, so this should be right. So you will still get updates and security updates for Java 8 until September 2018, but then you won't. And then you either have to pay for a commercial license to get these backported security updates. And I can already tell you, I'm working with rather some applications that actually trigger bugs in the JVM, as I'm a fairly low-level person. Oracle already today doesn't backport anything back to Java 8 anymore. Java 9 changed the code base so much. It's very much worth updating. Just the additions like string compaction, which you don't have to do anything for using these features, but there's a lot of big improvements in Java 9. So you should aim for an update, not decide to stick to Java 8 for the next 5 years either. But try out the application, see what breaks, test it out, report it to the library maintainers, because we library maintainers, we're really dependent sometimes on getting this feedback, because a complex enough library might trigger bugs that we're not even aware of with Java 9. And without the feedback, I see that in Mockito, we couldn't do it. So please try everything out. And I think you'll be positively surprised how easy it will be in the end to get going, right? Because these things...
Is now a good time for a couple of questions?
Yeah, sure.
Sure. Oh, excellent. So we have one in Slack, Rizwan, asking: are all the JVM classes and the old native classes now modularized within the JVM? So if we need anything from, say, com.sun, we will need to mention them in the modulinfo.java.
So, and that's a tricky part. You cannot reference these classes. You cannot override what a module exports, right? You can only demand a dependency. You can say, I want to depend on Java base. And if Java base includes something like sunmisc base 64 encoder, what it does, but it doesn't export the sunmisc package, which it does not, then you don't have any chance of accessing these packages, unless, and this is where I'm getting to now, unless you explicitly say so. So you can at startup specify that you want to export the sunmisc package from Java base to all unnamed, which is the unnamed module, which is basically a symbolic name for the unnamed module. And then this old application can still run, right? But this is painful. You have to probably go through a lot of packages if you really have internal dependencies and open them all up. And it's also not in the spirit of the JVM, because a big effort of Java 9 is to make the JVM more secure. And this is important. People don't like security because it's mostly inconvenience. A fully open platform where everything's allowed is of course harder to handle than a platform where you can access anything. But these classes allow you to basically circumvent a lot of things. And if you, for example, in the open source space, a lot of stuff is maintained like by a few people in their free time. If something goes into the wrong hands, then I could easily push a malicious update of Byte Buddy to main central. I'm sure nobody will notice because it's a big code base. And I could then just reflect over all classes in the JVM and basically get hold of everything that is in the JVM. But now I cannot, no longer. With Java 9, I cannot push such a malicious update because I only have access to my code. I cannot just parse all your internal classes and basically look if I find a string that looks like a credit card number and send an email to me. Because if I have full access to everything, I can do these things. And this is possible, right? And these things happen. I've never heard of an exploit like that in the Java space. But like Chrome extensions, people pay a lot of money for buying Chrome extensions from you if you have a lot of users to push you something to break out of the sandbox that other plugins would get. Sorry, that was a very long answer to a short question, but I hope I answered it yet. So
that's awesome. You got time for a couple more, or you want to?
Yeah, sure.
Dr. Shell, obviously a REPL fan. Is there any tool for assisting making modules from an old application? So I presume this is in terms of creating up the modulinfo.java based on your code.
Yeah, that would require you to repackage the jar. So you could do that, but And that's something I always say in relation to Java 9. I think this release will trigger that a lot of old libraries that are still fairly used but not maintained will die off. And I can tell, besides Byte Buddy, I'm also maintaining a bit of cglib, which I inherited somehow because I'm doing bytecode engineering and there's not a lot of people who have the knowledge of this stuff, which doesn't mean that it's difficult. It's just a few people care, since it's very particular. But I'm not planning to modularize cglib at any point in time. This library, I'm just basically keeping it alive because a lot of big projects still rely on it, but I encourage people to migrate to Byte Buddy as my free time doesn't allow to maintain two libraries. And that if nobody takes over, I think cglib will not be something that you want to be relying on in the future. And I think this will be true for the libraries as well. But maybe that's a good thing, right? Maybe it's good to have this sort of consolidation. If a library didn't get updates for many years, maybe it's good things like the phoenix out of the ashes. If there's no competition anymore, then another open source project might gain more attraction, gain more support and all these things. So this is something I expect to happen, yes.
Mm-hmm. And one from Nikolay, you may actually cover this in a minute. Does the module system come with circular dependency detection or compile time? And also, how does the module system work with different versions of Maven packages? So different versions in the runtime. I'm sure you're going to love that question.
Yeah, so circular dependencies are not permitted by the Java module system, which was another point of controversy in the process, because other module systems like OSGI or JBoss modules allow for circular dependencies. But I find circular dependencies, personally, I find it a rather weird use case. There's always a way to refactor circular dependencies into a better abstraction, in my opinion. And of course, people don't like to hear that because they have their reasons for having chosen this model. But it's always that it's a value of its own to be simple. And the Java module system is very simple. It's very approachable. A lot of people that work with Java maybe come from another language. They don't have that much experience. It is important that the Java module system is simple. And OSGI is not simple, and JBoss modules is neither. I had hard times explaining OSGI to other developers on my teams, and they make mistakes because they don't know how to use it. So this is a good property. If you need circular dependencies, use OSGI. It's a great module system that supports a lot of advanced stuff, but most people won't need that. So that's what the Java module system is good for. The basic use case, the standard use case. And maybe it gets an extension one day if people figured out how to do it right. It's always, I mean, you notice from your projects, it's probably better to add an API once you figure out how to do it right before just exposing something that you're stuck with forever. What was the other question was?
Versions.
Yeah, versions. No, yeah, the so-called jar hell. No, that's not resolved, and that's neither the point of the Java module system. You can only have one version of every module in a project. And I wrote a long and extensive blog post around this, why neither OSGI and JBoss modules who claim that they solve this versioning problem, they neither allow for a proper resolution of multi-version modules, because the way they do it is basically they discriminate two versions by their class loader, which makes these classes incompatible. If you rely on two modules of a different, one module of two different versions, you're in trouble to begin with. You can, of course, shade dependencies. This is something that people have always done in JVM. And I think discriminating by name over class load is a much better solution, to be honest. If you rely on a very extensive library, like Byte Buddy also, in a way that you use it, that you actually interfere with internal APIs that will break over time, then you should shade it anyways, because then your usage is not safe. But the point of the module system is to disallow usage of these internal APIs, and then library vendors like me also, we just have to get used to not breaking APIs. Guava just has announced that, right? Guava was permanently deleting APIs from their from their official API every half year or so, which makes Guava a terrible library to depend on. They just said, like, okay, after 6 years of doing that, we found out that this is quite a bad of an idea. We will stop now. So in the future, I hope that these problems get much less just because people do it properly. Right. Yes. So Are there more questions? Or?
No, that's everything. Thank you.
Okay, perfect. So yeah, just shoot away if you have them. I rather pick them up on the way, which makes it much easier to answer them because we're still in the topic, right? So of course, short run, you might not be happy with the solution because the base64 encoder might not be imported by your code, but by a dependency of yours that you cannot change, right? And then you should give those maintainers of the library a note, please resolve this illegal import. But for the time being, you can on the command line add an export and basically make this explicit. You can also, there's a programmatic API, module add exports, where you can basically say, I want to add a package to an export. The tricky part is that you can only call this from within the module you want to export from. But if you have a library, you could, for example, say, optionally, I allow for adding an export if a flag is set or something to make a module backwards compatible, right, to non-modularized applications that did not fix the imports. And I just issue a warning of my own. And of course, there's my favorite API in the JVM, the instrumentation API, which basically allows you to access anything and to change everything. There's also a method now that allows you to change a module where you can basically resolve any conflict also, because this restriction that is in place for module exports doesn't exist for the instrumentation API. So in Java agents, for example, they can make use of that to circumvent modularity, where Java agents have actually good reasons to do that sometimes, right? That's why the API is there. The most infamous class of the Java virtual machine is probably sunmisc unsafe. And sunmisc unsafe allows you to do a lot of useful things, like for high performance libraries, it gives you direct memory access to avoid garbage collection, which is a rather expensive operation. It allows you to, for example, instantiate classes without calling a constructor by just allocating memory, which is very useful for example, Mokido as a mocking library and other things. And there was long a discussion about this, and people rioted, including me, because this would have put us into trouble if this class disappeared. But fortunately, there's a module in the JVM now that is called JDK unsupported. And it includes sunmisc unsafe and 3-4 other classes, like the cleaner class and all these things, which are hopefully superseded in the future by better APIs. And for direct memory access, you now have var handles already, which will be the future of direct memory access, which is a much better solution than sunmisc unsafe. But for the time being, you can simply add or rely on this class. Libraries that need sunmisc unsafe, which are quite a lot of them exist out there, they will still work. That's why Mokido, for example, still is able to run on Java 9 the way it did on Java 8, because this did not go away. And we don't have yet a good replacement for the APIs we rely on. And we hope in the process of Java 10 or 18.3, I think now is the planned name for the release. We hope to, Oracle is fairly open. If you tell them something, and you have a good reason to need that, they listen. So this is my experience. So we have some time to fix these issues. So just go on the mailing list if you have something. So you can just require JDK unsupported the way you would require any module, and things work. And of course, from a Maven project that's not modularized as the unnamed module, you implicitly always rely on JDK unsupported. So this works. Yes. Let me see. How much time do I have left? 10 minutes? Is that right?
Yeah, we've got about 10 minutes.
Yeah. So I'll just do this quickly. If you load a class from the class path, then today you just specify 3 jar files, for example, and they will be put on the class file in this order. Whenever you load a class, like if you start your program with package main and you want to load a class foobar from this jar file, the JVM will search. Basically, this is the searching algorithm. It will iterate over all these class files you specify in their order. And once a jar file contains a specific class, the JVM will load this class. And if it doesn't exist in any jar, it will throw a class not found exception, or no class def error rather, right? And this is the search order. So if 2 modules, 2 jar files contain the same class, foo.bar, then only the first one will get loaded. And this is, speaking again about security, this is an actual potential attack you can run on a JVM. You can just sneak in a jar file somewhere, or you have a library and you just add a jar file in a different package. like foobar. And if you know there's a popular library being used, like Hibernate, for example, you can just replace one of the Hibernate classes with a working copy, which then also does this credit card scrapping for you, right? Every time an entity gets persisted, you check if any of the fields contains a string that's a credit card number, and you send this per email to your server. So you could do this with the class path quite easily. That's, of course, not a very satisfying solution, and you have mechanisms like, how's it called again? Package sealing, where you can declare that a package cannot define classes in different jar files. But in order to do that, you have to be the first class that loads this package, right? And if I'm the first one that's on the class path, then I can define if the package is sealed or not, and I can say it's not, and things will just work fine. So let's be a minute. How would I do that, right? I'm maintaining Byte Buddy. It's a fairly widely used library, since it, not because it's so popular, but because it's having so many transitive dependencies. So popular libraries use it, which makes my library popular in a way. If I included Hibernate, the full Hibernate thing in my jar file, but added this credit card scrapping, and I would push an update, again, I'm sure nobody will notice these things. So I can then probably, and Byte Buddy now it's growing insanely. I'm at 40 million downloads a year. So I will probably end up with some credit card numbers. Or let's say I'm not that much of a crook, but if someone steals my credentials, gets access to my upload chain, and can push a library with my GPG key to Maven Central, then this can happen, right? So this is something that's possible with the class path. So that makes the JVM sort of unsafe if you rely on dependencies you don't rely on. With the module path, you still define these jar files, but they are modularized now. And if two jar files contain the same package, right, Hibernate in this case, then the algorithm for loading a class now looks like this. Every package is now exclusive to a module, and I can say I get the package name of a class, then I find this single module that contains this package, and then I load this class. If two jar files define the same class, or the same package rather, classes in the same package, then the JVM will no longer start up. It will say there's a conflict. Look at this Byte Buddy jar, it contains Hibernate, org Hibernate namespace, and look at this Hibernate jar, it also contains org Hibernate classes. There's something wrong here, have a look. And that is actually, as I said, it's maybe less convenient, because you might have these package name collisions by accident, but it is much more safe. And in the end, you want more safe because everybody screams out loud if there's a security vulnerability in Java. But people also scream out loud if there's something no longer working that they expect to work. It is inconvenient if you use very generic namespaces, and I'm an enterprise developer, as I said. There's always someone who defines this util.myutil class in a project, and then this name is used in several modules or Maven jar files. And now you have to refactor that to have basically every module needs its exclusive namespace from now on. And this is a change that Java 9 just requires you. Also, if you're using old code, right? Even on the class path, even with all restrictions, unless once you use modularization with jar files, you have to adhere to this rule. So be extra careful from now on to only define packages that nobody else will use. This reverse DNS notation. So my company, some module, that's a good start. And then you avoid these conflicts and you get a lot of security just for free. Yes. Clock 5 minutes. Yeah. So now I have my bonus slides soon. I will not make all of those, but the slides are online if you just want to click through them. And I gave this talk many times before. Just find those talks if you want to see more. So let's just look through the modules you have available now for almost the last segment of the talk. Of course, I mentioned Java Base. We have now Java Logging, which contains the logging API that nobody uses. Now you will not confuse the logging API anymore with a simple logging facade for J once you want to import something. That's a great time saver, actually, because that happens a lot to me. So you have the Java instrument package, which is containing all agent-related stuff. You have data transfer, scripting, and all these packages. And most modules just depend on the Java base module. These are pretty clean restrictions. Java SQL, for example, contains the JDBC API, which is a rather used API, but not all modules need SQL interaction, right? And you can now see that in order to do SQL, you actually need to do XML as well, because some SQL databases support XML types, which are represented by the XML module. And unfortunately, you also need Java logging, which is just based on compatibility with old APIs which are already interacting with the Java logging API. There's a lot of APIs and modules. I very much recommend you to go through these and see what's in there. For example, the Java SQL row set API. I only found out that these classes exist while looking through this module there. And not going into details here, a few of these modules are deprecated now. And for example, java.corba is now deprecated, or java.transaction is deprecated, which is like the two-phase commit API, which doesn't really belong into a standard library. And at the time, people thought differently, and that's fair enough. Especially Corba was big these days, and basically couldn't run a platform without offering Corba, so why not include it in JVM? And the problem is, mostly with these things, first of all, if you really require Corba, you probably want a more updated version of a Corba protocol. So you cannot really use the one that's included. So you want to version it outside of the JVM. And the nice thing now is that with these deprecated modules is that they will be removed in the future. So the JVM will become quite a bit leaner. And that is good news, because the JVM runs this Ponzi scheme, right? Where every class that is included is staying there forever. And on the long run, this will no longer work, right? You cannot, 21 years, we only added code to the JVM. And the JVM is now 200 megabytes something because of that. And of course, memory grows, but you want to have a lean platform. We work a lot with cloud storages now and with containers. And I think that's one of the reasons that Oracle pushed for Jigsaw, despite the costs and the costs not only in development, but also to developers. This is painful, but it allows to use these deployment models much more efficiently, which assures that Java has a future in this changing world of software development. Support these things. Nobody wants to deploy a half gigabyte container in the future. You want to have lean packages, and that removing stuff is required for that. So now you can still use them in Java 9, but they will go away eventually, right? And it doesn't mean that they're not useful, like Java XML binding the package, because JuxB is useful, but you probably don't want to version it within the JVM. So now we can correct these decisions, right? And a nice thing, and this is one of the features that thrilled me the most about Java 9. You can now even build artifacts that include the JVM only to the extent that you actually require it. So, well, that's the wrong slide, actually. Let's go with this one. With jlink, which is a new tool in the JDK, you can now say, okay, we have the module part, which includes Java Home, and your custom module folder. In this case, it's called mods. And then you say, I want to add the module example foo. And example foo has a launcher class, which is called run, which is the package main class, and output this build artifact to my app. Then Java 9 builds you, oops, the color here, this folder, which is a fully self-running JVM, including your application. And only includes the JVM to the extent that it is required. That means you can run my app bin run, right? This is the launcher application. It's a shell or a bin file, depending on the platform you build on. And it prints what you basically coded in there, hello world, if that's what package main does. This is the result now, right? And if you list the modules of this Java installation that comes with this application that was built, it just lists the modules that you included, which is, in this case, I just included Java base. And the size of this folder, my app, is 44 megabytes on my machine. Actually, this is an old release. It's even leaner now. It's a bit 35 or something. So you can now build a JVM that you can ship to your customers that includes your entire application, which you tested and everything, which is basically your full application, runnable and everything. And compare this to the 200 megabytes that this application would have as a base image profile before. Makes containerization also much more better. And I think I'm through now, am I?
Yeah, that's pretty much. I was just going to stop you at that after this slide anyway, but that was awesome. No, that's. Yeah. I mean, there is so much. You could go another hour on this. I'm sure.
Yeah, no. When I made this talk, I ended up with about 250 slides, and that's just the module system.
Yeah.
So I can of course go on forever. But yeah, thank you so much for having me. I'm Rafael.
It's our pleasure.
I'm into the last words.
Absolutely, our pleasure. Now let's see if we've got 5 minutes till the next session, so I want to keep a couple of minutes spare. But I want to jump to hang on, let me see. I want to jump to Melbourne quick. Any questions from the Melbourne room?
All right. I've got one while we're moving the mic around. Is there anything stopping me from having a internal package in one module, but then having another module that also has the same package but exports that and then takes precedence?
Yes, this concept is called it's concealed packages. Yeah, this is no longer possible. No, and that's a criticism Java gets because OSGI supports that. But if you think of it, it's not really a good abstraction in the first place. But the JVM maps every packages exclusively to a module, independently if it's exported or not. And that's why this is not possible. And people argue it should be possible, but I think it's quite a little price to pay for getting this extra security. But no, you cannot do that in order to answer the question, no.
That breaks my hacking plans, but thank you very much. One question down the back.
Yeah, if I'm a Java developer writing a basic Spring Boot app, what's the extent of my concern with modules? Is it just a matter of making sure the frameworks and libraries that I'm using are up to date and support Java 9, or are I explicitly doing module-specific stuff?
Well, Spring Boot or Spring in general is an integration framework, so they work as well as the libraries they integrate against. But as far as I know, with Spring Boot 2, they want to basically update all of their internal dependencies or their integration suggestion dependencies to versions where modularization does work out. And in the open source community, a lot of work was done in order to accommodate modularization. So I think updating to Spring Boot 2, if you don't have other dependencies that are not bound by Spring Boot, should work out just like that.
My question was, let's say all my dependencies up to date, I'm using Spring Boot 2 and Java 9. Do I need to modularize my own code?
No, not at all. So the class path is there to stay. The class path will not be removed. You can, of course, optionally use the module path, and Spring says we are ready for that. But if you choose to not use modularization, unless you access internal APIs of the JVM itself, which is no longer allowed, you can just keep everything the way it is. And I think a lot of people will choose that as well, because sometimes an old app doesn't really pay off to update everything if things are working well. It's your choice. No, there's no forcing.
Just a question. So we have a application which we are designing in OSGI, and as a framework, I love it. But based on the explanation which you gave, so what are your thoughts on using OSGI and Java 9 together? Because OSGI is like a big umbrella altogether where you have more flexibility.
Yes, so there's no problem in using Java 9 with OSGI, but you probably will not use the Java 9 module system because OSGI is basically taking the role of the facilitator. But with OSGI has the clear disadvantage that it isn't bound to the JVM. It cannot restrict access, for example, using reflection. It can only rely on a security manager, which is less safe generally because security managers are often overdoing things. But you're perfectly free to use OSGI. If this works for you today, this is the way to go. You keep OSGI, you update to Java 9, you just opt out of the Java 9 module system and use OSGI to load your bundles. And this works. And as I said, OSGI can do great things for you that the Java module system doesn't support. And few people need that, but those that need it should totally stick to OSGI. Yes?
Okay, we've got a question here as well. We've got a slight delay before the next session, so I'm going to just do a couple more questions, or one more question actually. So we have a question from Patrick asking, with modules internals now being protected, what are the consequences for clients or libraries that do touch the internals or transform classes? For example, Hibernate, Eclipse, Link, anything with JPA really, I guess.
So I mean, these libraries are mostly refactored to not touch any internals anymore. But arguably most usage of internal APIs were required. So, but now Java 9 added new APIs, and that's permanently still adding new APIs. So these things get refactored. So as long as you update, yeah, you should be safe. But you have, of course, you're in responsibility to open your classes to Hibernate or Spring in order for them to access your stuff, right? But you have the power to do so. Did I answer the question? I'm not sure if I.
Yeah, I think that's pretty much it. I mean, it's, opens is the key, yeah, I guess, to doing that. But that's awesome. Well, a massive thank you to Rafael. Great masterclass in modules. And if there's a few people that would really give a session like that well, and you did that spot on. So thank you.
Thanks, appreciate it.